I intended to get a hour meter and put in here so I keep track of the hours on the lathe that it's running. Well, I went to town to get one, and all they had down there was 12 volt ones. Looked online, and 12 volt or DC ones were easy to come by. I needed a 110 volt one. There is a DC circuit in here that supplies voltage to the halogen lamp, or the LED lamp as it is now. But that is hot all the time, so that would just keep continuously counting. And I want to hook this up so that it just comes on when the motor is actually running. The only ones that I could get in the US were a couple $100. I did find some in China here, and I think this is like 10 or 15 bucks including shipping. The only problem is it took a month to get here, but I've got it now. So I'm going to mount it. I think I'm going to mount it right here in this electrical box facing to the front, so I don't have to go chasing around looking at it. Someday this thing might be sitting up against the wall, or closer to the wall, and be kind of hard to look at. So looking in here, just about dead center, there's plenty of room in there for this to fit in. So I've unplugged the lathe. I've taken the back plate off of the cover plate off the electrical box, and I'll mark this out to put this hour meter in there. I got my hole cut out for the hour meter. I marked it out, laid it out with a marking pencil and a square on there, found the center on the back and transferred it over here to the front, and then marked out the width and the depth of that box for the hour meter. Then I took aircraft 1/8 inch extension bit so I could handle the drill from out here, and drilled the corners of those, all 4 corners. And I took a Dremel with a little fiber wheel, cut off wheel, and cut it out. And I did it all from the outside here. Of course, it's hard to get to the inside, but I wanted most of the chips and shavings to come this way. So that's done. This thing fits in there pretty good now. Oh, that's good enough. I'll mark these. Got holes marked there for screws, and I'll drill those holes out for sheet metal screws, and then I have to get some wires and make up a wiring harness for that, and then figure out which terminals to hook that up to in there in the box. I found a couple of number 6 machine screws, stainless steel Torx head. These are what I was using in the airplane. They call for a number 31 drill bit for a hole for the tap. Well, I started to drill that out with a number 31, but I don't have a 632 tap. The 1/8 inch drill bit is pretty close to a number 31, so I went ahead and drilled those out with an 1/8 inch drill bit for the screws, and just screwed those in there, and they threaded in there fine. So that hour meter is mounted on there now. I want to try to hook it up to something that supplies power when the motor is running and not the rest of the time. So I'm going to have to do a little calculating on that and figure out which terminals to hook that up to. But I've opened up this electrical panel to try to figure out which wires that I could use to jumper in the wire for the hour meter. I need a 110 or higher voltage hookup for that, and I want it on something that comes on when the power is on, and not just when it's plugged in. Some of this stuff is hot when it's plugged in. For example, the light circuit is hot with it plugged in. So I opened this box up, and I started doing some checking here, looking. I've got my line diagrams over here out of the book. Well, we got power that comes in right here. This is the supply line here. I've got both sides of the 220. You've got 110, 110, and then we've got the neutral or the ground here. And then we've got these wires here all go to the motor. As near as I can figure, this number 2 wire here, when I turn the emergency shutoff button on, when I make it contact, then that supplies 120 voltage to this number 2 wire, which goes to the control panel, to the main power switch and stuff there. So I can jumper in on this with a lead to go up to my hour meter, and then that should turn on and off when the cutoff switch is shut off, the emergency switch is shut off. I've come to kind of an impasse here on this hour meter. Tried hooking this up to different outlets, trying to find a switched 120 volt supply that could trigger that hour meter, and I thought I had it with this number 1 wire here that goes down to trigger that goes to the emergency cutoff switch, and then that activates the main power switch Those all metered out to 120 volt, but when everything gets turned on, the voltage drops down on them, and it's not enough to trigger that hour meter. Still trying to figure out something, but I thought maybe this circuit that went for the light was 12 volts, but looking on the transformer, that's 24 volts. Anyway, I run the line down for the hour meter down here and hooked it up into the leads that go into the motor, and they show hot all the time whenever the thing's plugged in. So I hooked it up to one of those. The hour meter works on that, but it's on all of the time. And you can do that with a light circuit or even this number 1 wire here. Whenever this lathe is plugged in, all of those circuits are hot and they don't shut off. So I don't really like that, and I can't find an alternative in there yet. I can still do some poking around, but so far I've been unable to find an alternative to finding a switched 120 volt circuit in there, or a circuit that I can tap off of to run my hour meter. Oh, what I've done, I ordered a magnetic switch, a 220 volt magnetic switch, and I think I'm going to wire that in. Like I said, I don't like the idea of having power to this thing all of the time when it's plugged in. It's the only way you can shut this down is by unplugging it. Otherwise there's power, and it's power coming in. Of course, these leads here are hot. This is the supply line, but all of these motor leads are hot, and this number 1 circuit's hot. The circuit going to the LED light is hot. Nothing shuts off. So I'm going to get a magnetic switch and put in here, and then I'll run my supply line into the switch and then run it over to the feed into the lathe, and that way I can turn this lathe on and off when it's not in use, and that way I know there's no power in here. None of this stuff is going to smoke, burn up, catch on fire, burn the house down, or anything else while it's unattended. Anyway, that's what we're doing now. I'll go ahead when I get time and do some more investigating on this and see if I can't find a switch circuit that'll work for that hour meter. But in the meantime, I'm just waiting for that magnetic switch to get here so we can wire that in. It's a beautiful day outside today. Bright blue sky, sunshine, clear as a bell. It's dry, but it's cold. It's just too cold to do anything in the hangar. Even if I turned on the electric heaters that are in there now, it'd still be too cold to work with bare hands in there. I guess I'm stuck here in the basement working on stuff here. Well, I'll get back to a project that I started a few months ago. I've got this 12-inch Grizzly lathe. It's a G4003G. I wanted to put an hour meter on it to keep track of the time on it and stuff. So I got a 110 volt hour meter, and I picked a spot here, and this is the electrical box here on the back of the headstock. And I found a spot there to mount it in. This red button is the master switch kind of on here. It's an emergency switch, and that's the one you got to push in to get the power into the head and everything. And I tried to wire it into that so that the hour meter would only run when the lathe was actually on. But when I'd hook it up to that, it wouldn't trigger the hour meter. So I have the hour meter hooked up to 110 side of the input line, and that's fine. The hour meter works on there. The only problem is that it's on constantly whenever the machine is plugged in, and that is one of the problems with the machine. Even though it has a power switch here that shuts off the power to the controls and everything, the motor and everything, when you're not using it, it's still hot in the box here. There's no way to turn the power off to it except to unplug the machine from the wall. So what I decided to do was go ahead and get a switch for this, a master switch for this, that I can turn the thing on and off, so I don't have to reach down and unplug it and plug it in every time I want to use it. I did get a switch for it, and I found the least expensive switch that I could find that would work on it. It was a Shop Fox switch, which you could have got through Grizzly or a couple different outlets, but the least expensive places to get it I found was on Amazon. And it's a magnetic switch, so when the power goes out on this, you'll have to reset the switch. Started looking for a place to mount it, figuring out where to mount it, and it looked like the best place to me was here on this side. I can reach around from the side and turn it on and off, and any place else on it is kind of out of the way. It'd been nicer to have it up front where you can get to it right away instead of reaching behind everything, but this is the the best place that I can find to put it. Well, I laid it out here to cut out a spot for this to fit in. And I could do this two ways. This switch is snap locked into this faceplate here, so we could take the switch out and just mount the plain old switch in there. This faceplate is the size of a regular household faceplate, but the nice thing about the faceplate is it has this great big paddle for an off switch that you don't have to reach in there and find that button. You just hit that and off it goes. So I think I'm going to go ahead and leave it like that with the faceplate on there. It's a 220 volt switch, so I can run both inlet leads into here and run these out to the circuit in the machine, and that'll cut off both sides of the power whenever I want to shut the machine down. So I've set this out to where it's in a good spot here. Getting it any farther forward runs in, gets it awful close to the power strip in here. So this gets it back out of the way of that, where I've got enough room to get behind there with the wires and got it centered there close to the edge. And that's up nice and high where you can reach it. The cover that goes over this pulley and stuff, I've got it off right now, and that comes out about here. So this is behind it and above it. Well, I've got it all laid out for exactly the size of the switch itself. Well, I've got the holes drilled out in the corners, and I can take something and cut that out. I think I'll take the Dremel tool with a cutoff wheel on it and cut down these lines and cut that out and mount the switch in there. I got the hole cut out for that switch. I want to take a little file here as a safety file or chainsaw raker file. Just dress up that hole a little bit, deburr the back side of it, dress it up a little bit. Okay, that's pretty good. Nice and clean on the inside. Now I got the power off in there, of course, so I don't have to worry about jamming anything into a hot circuit. Alright, that fits in there good. Now I need to drill out those holes, put a screw in them to hold that plate on there. I undid the grommet, the nut on my lead-in cable, and pulled through a foot, a little more than a foot of it, and stripped it back and put spade connectors on there. Well, I got that done. I cut the ground wire off and put a new fork connector on it. It shortened it up so it wasn't so long, and then I dug out some wire and made a new wire to go from the switch down to the terminal block on that for the input. So we've got the hot lead coming out here, in here, tying into the switch, and then this would be the supply voltage into the machine here. So this is all hooked up. My switch is hooked up. You're ready to go in here. I can bolt it in now, and I'll hook I've got my feed cable hooked up in there, and I'll get my supply lines hooked up to the terminal, and this thing will be ready to go. I took some solvent and cleaned up my marks on there that I used for laying it out. I need to get the vacuum cleaner and get in there and clean out the shavings and stuff from cutting the holes in here and whatnot. And I'll put the paddle back on this switch, and we'll give it a try, see how it works. Well, as the saying goes, the proof of the pudding is in the eating. Got everything all hooked up there, so I'm going to plug this in and see what happens here. Now the reset button doesn't do anything. One of the other indicators I got is this work lamp here, and I'll turn it on. Nothing there. Well, now let's see what happens. Okay, the work light comes on. If I punch the reset switch, I get power. There we go. Okay, that works. Now let's see what happens. Hit the paddle, off it goes. Everything's shut down. Cool. That worked just like it was supposed to. And I don't hear the and now I can hear the meter. I couldn't hear it before. Yeah, see, I turned that on and the power came back on here. So alright, I like that. And no smoke. That's good. Well, I can put the cover back on the circuit box back there, the electrical box, and that part is done.